Okay, let's see how to solve some problems on chemical kinetics we have on the board. Note that the Arrhenius equation, that equation we mentioned in one of our videos or in the beginning part of this topic, the equation is a graph of Lincare against inverse of temperature. It's a graph of Lincare against inverse of temperature. Okay, note it. Have it in your mind. We have discussed it before now. Graph of Lincare against inverse of temperature. Okay, let's go to the first question we have. The initial concentration of N2O5 in the following first order reaction was this. So this is the initial, our CO at this. The concentration of this after 60 minutes. So 60 minutes is telling you time. After 60 minutes was this. This is our normal C. Calculate the rate constant of the reaction at this. Wow. The initial concentration of this following first order. So because they say following first order, we will recall that length C is equals to ln CO minus KT. Okay? Then what is our C? Our C is 0.2. Say now, packaging ln 0.2 times 10 raised power minus 2. Is it my when this come this side, it becomes minus what? Ln what? 1.24 times 10 raised power of minus 2. We say is equals to minus KT. And what is our care? Did they give us our care? No, we are looking for the care. They say find the what? Rate constant. But they gave us the time, 60 minutes. And so what will happen is that we now tell them that our care will be equals to this our care will be equals to ln bracket 0.2 times 10 raised power minus 2 minus ln 1.24 times 10 raised power of minus 2 all over minus 60. Carry minus 60, go the other side. Now you use your calculator. In your calculator is your scientific calculator. You see lane there. You say lane, so you package it this way. I package my own. This will be giving you a negative answer. Okay, and so divided by negative 60, our care will be equals to 0.0304 per minute. So use your calculator and confirm it and comment on the comment box below so that you verify this answer. Now we go to question number 2, which says a reaction is found to have a rate constant of K equals to this. Find the half-life of the reaction. As we discussed before now, we have many formula for half-life of what reaction? Half-life of zero order, first order, and second order. So which one should we use? We do not know. So what you do is that check the value of K. What unit is it? Look at K is equal to this per second. Per second means it's talking about first order, because we say in first order the half-life in first order the K, the unit of your K, which you call rate constant, is equal to per second. That is the unit of what? K. And we now say since it is in per second, that means watch that half-life we will use, it will be half-life of first order, which is 0.693 all over K. And what will it give you? 0.693 all over 5.5 times 10 raised to the power of minus 14. Okay? 0.693 all over 5.5 times 10 raised to the power of minus what? 14 per second. Remember the unit of half-life is second, but here the K unit will be per second. Are you getting it? And when you do this, it will be giving you, therefore K half-life should be equals to 1.26 times 10 raised to the power of 13 seconds. You get? Because here is per second, so the unit of this one should be in second. 1.26 times. So just use your calculator well, use your scientific calculator well, and you will verify this answer. As you verify it, use the comment box below to tell me yes or no. For question number 3, a first order reaction has a rate constant of this per second. How long will 5 grams of this reactant take to reduce to 3 grams? To reduce to, so this is the final concentration and this is the initial what? Concentration. So we go to the formula that says ln C, because they say per second, that is first order, is equal to ln CO minus what? KT. Our CT is 3, ln 3 equals to lane what? 5 minus what is okay? The care is given to us as 1.15 times 10 raised power minus 3 what? T. So we are looking for the time it will take to reduce to this 3. And so from here, we say take this to the other side. We'll be having lane 3 minus lane 5 all over minus 1.15 times 10 raised power minus 3 equals to what? T. So you package this inside calculator. Remember, lane is not the same thing with log reading. So lane is what you will use, not log reading place. You package inside calculator to get your time. What you'll be getting your time is your time it will take the 5 gram to reduce to 3 gram will be 444.2 seconds. Seconds because the rate constant is in per second. If the rate constant is per minute, you put minute. If it's in hour, you put hour. If they ask you to convert seconds to minutes, you divide this second by 60. When you divide this second by 60, you are getting it in minutes. When you want to get it to what? Hours. You divide it by 444.2 all over 60 will give you the answer in minutes. Then 444.2 all over 3,600 will give it to you in hours. So whichever one they want you answer to be, please package it well. We go to the last question. So in the last question, it said the first order rate constant for the decomposition of ethyl iodide by the reaction days at 600 Kelvin is this. Its saturation energy is 209 kilojoule per mole. Calculate the rate constant of the reaction at this. Remember, R is joules mole per liter per Kelvin. Okay? And so what we do is I will recall Arrhenius equation, which says that K is equals to A exponential minus EA over RT. And from here, this is when only one rate constant is given to you. Only one rate constant is given to you. But when more than one rate constant are given to you, you said that it is link K2 minus link K1 equals to EA over R bracket T2 minus T1 all over T1 times T2. And so they are giving you the parameters. So what we will be doing, we'll package lane K2 is what I'm looking for, equals to what? EA over R bracket T2 minus T1 all over T1 times T2 plus lane K1. Okay? What is our EA? EA 209 kilojoules, that is 209,000 joule per mole. So we now say that lane K2 will be equals to 209,000 all over 8.314. This R is constant, universal gas constant. Now, this is your final temperature, which you are looking for, and this is the initial temperature. So it says 700 minus 600 all over 600 times 700. Okay? 700 minus 600, 100 over 42, 420,000, right? So, lane K2 will be equals to 209,000 all over 8.314 bracket 100 all over 420,000. There. So, this will require you making use of calculator. Yes, it will require you making use of calculator. Then plus lane what? K1. What is your K1? Your K1 is 1.6 times 10 raised to the power of minus 5. Okay? So plus, if you check lane of this, lane of 1.6 times 10 raised to the power minus 5, it will be giving you minus 11.0. It will be giving you minus 11.043. To be giving you minus 11.043. Are you getting it? And so, if you compute this, please use your calculator to compute it. This times is divided by this. What it will be giving you is that lane K2 is equals to, you compute this, it will be giving you 5.9853. 5.9853. So you combine it with this 11.043. it will be giving you that link K2 is equals to, if you subtract this, it will be giving you 5.0577 minus 5.0577. Just confirm it with your calculator. Okay. Then, since our lane K2 is this, lane, what is our K? K2 will be equal to exponential, because you are dealing with lane, you use exponential, minus 5.0577. Okay. K2 equals to exponential raised to the power of minus 5.0577. And that will be giving you 6.06. 6.36, please, not 6.36 times 10 raised to the power of minus 3 per second. 6.36 times 10 raised to the power minus 3 per second. That is the value for this question. So the final rate constant will be 6.36 times 10 raised to the power of minus 3 per second. Thank you guys for watching today's video. Please feel free to click like if you enjoyed the video, share with your friends, comment as well, turn your notification button for more videos that will upload. Thank you. See you next time.